Hello and welcome to a short introduction of our position paper, a call to action for a human-centered AutoML paradigm. This is our position. We believe that we need a more human-centered paradigm in AutoML, enabling efficient and collaborative design of machine learning systems by leveraging the best of both worlds, human experts and systematic AutoML. Why do we believe this? Well, if you're a machine learning engineer, data scientist, researcher, you've probably seen some version of this figure. The machine learning lifecycle, workflow, whatever you want to call it. AutoML and machine learning operations are kind of dealing with making the right-hand side of this figure a bit more manageable and user-friendly, and AutoML especially is concerned with the modeling part of machine learning, so the middle circle. But by automating it, it also closes it off and doesn't give human experts a chance to interact with this process. So we think it would be better to break this up a little and include human experts into AutoML, make it interactive, make it explainable. You can already see the different roles with respect to AutoML and what different needs or expectations they might have towards an interactive AutoML system. And we will revisit these roles a little bit later. But for now, let's have a look at what AutoML has actually set out to do, what it has achieved so far, and what its current problems are. So AutoML is really trying to accelerate the pipeline development in machine learning by helping out with hyperparameter optimization and model selection. It can also support the research for new algorithms, and I think the overall goal for AutoML has always been to democratize machine learning to make it more accessible to those that have minimal machine learning expertise. It has accomplished quite a few impressive feats in the past. It has definitely improved current neural architectures. It is very heavily used. There are some very heavily used packages going around, and it has even helped learn new algorithmic components for machine learning. However, there are some current problems that we would like to shed a light on, namely that systems are very rigid and have a very narrow focus on certain tasks and are therefore not really usable for a lot of applications. They often lack human interaction, explainability features, just any kind of iterative process, and they definitely still need some efficiency improvements for very large models, as current generative AI and large language models are demanding for especially efficient algorithms. In machine learning, we have different levels. We have a machine learning model that is being created by a machine learning algorithm, which is all orchestrated by the AutoML system. And there are different user groups interacting with this whole process. They might have different needs, where a domain expert might be interested in using custom performance metrics, a data scientist might be interested in adapting the configuration space of AutoML with certain methods or operations they know work well in the current use case. Machine learning researchers, on the other hand, might be interested in analyzing pipeline choices or different effects of hyperparameters. And of course, if you go kind of from one task to multiple tasks, this gives you a bonus user group, which is the AutoML researcher, which again comes with their own needs and expectations towards the AutoML system. The central part of our position paper are 5 hypotheses connected to human-centered AutoML. We believe that transparency and interpretability are key for machine learning and automated machine learning in many applications and on many different interpretability levels. We also believe that customizability and flexibility are essential to leverage the potential of AutoML for different user groups, simply because they have such different needs depending on the current situation. AutoML tools must also integrate with the data science workflow, allowing for an iterative interaction with the user, simply because, well, in reality, the workflow is seldom linear, but you kind of go back and forth between data-centric work and model-centric work. Since human experts are essential to machine learning processes, AutoML will only reach its full potential by collaborating with them. And finally, human-centered AutoML empowers users instead of making them dependent on a system they do not understand, which is arguably the case if you just kind of close off the whole modeling process by another black box that is current AutoML. Finally, we want to highlight some future research directions for human-centered AutoML that we think are especially important. For one, trust and interpretability for AutoML, a very interesting topic, because we believe that model interpretability, which has been embraced by the community, is very different from AutoML system interpretability, for example, when talking about effects of hyperparameters and their importance. Another area we would like to see put emphasis on in the future is the combination of algorithmic AutoML research and human-computer interaction AutoML research. We believe that there could be a lot of benefits in collaborating more closely, especially when it comes to interfaces, which is a common topic in HCI research. Talking about interfaces, we think that better interfaces for AutoML are crucial for the future, especially since domain experts struggle with the more technical interfaces that AutoML currently has. And finally, we would like to see AutoML extended to AutoDS, so automated data science, and this should extend to the human-centered paradigm because we believe that automation and interactive and explainable automation is relevant across the machine learning lifecycle and not just for the modeling step. That is the end of our presentation. Thank you so much for listening, and please check out our paper or come visit us at ICML.